Hello and welcome back to another LeetCode problem. We're looking at another one from the LeetCode 150 list from the math and geometry section. This one is the LeetCode 73, set matrix zeros, and it's a medium problem. So let's have a quick look. I'm going to show you two approaches how to solve it. One that is super quick and one that is smart. All right, so what are we dealing with? Well, we have an integer matrix that is an m by n matrix. And if an element is 0, then we should set its entire row and entire column to zeros. And we must do it in place. So we don't have to return the matrix. We just need to modify it. And yeah, let's look at an example. So here we have a very nice example. And as you can see, in the first example, we have a 0 right here. And that means the entire column needs to be set to 0 and the entire row, which is exactly what we get here. Right, cool. Second example, same thing. We have the first column and the last column have a 0. That means we have to set those to 0. And we also have to set the top row to 0. And that's exactly what we see here on the right side. Now, I'm thinking that, well, why don't we just iterate over the matrix with an x coordinate and a y coordinate, the x over the columns and the y coordinate over the rows, and we just memorize in which row and column we've seen a 0. And then we do another pass with our x and y coordinates across the matrix and check whether the x and the y coordinate exist in, the sets or the columns where we remembered that there were zeros. And then we just write the zeros. So just because we should modify the matrix in place doesn't mean that we can't use auxiliary space to compute the result. To do it in place just means that we have to write the result back into the matrix. So why don't we just do this real quick? So we say width is the length of the first row, and the height is the length of the number of rows, matrix, and well, we just iterate over all of the cells. So we iterate over the height, and we iterate over the width, and then we just do if matrix in the row y and column x. Well, if that is equal to 0, we have to remember this, and we will do this with two hash sets. 0 colts, that's going to be a set, and we're going to have 0 rows. Good type. Okay, cool. So yeah, if that is the case, well, then we're just going to add, well, current column, which is x, to our 0 colts, and the current row, which is the y coordinate, to that. Right. So now we have built up those two sets, and now the second pass is to loop over the whole thing again. But now we're just going to check whether the x coordinate is in colts, and or the y coordinate is in the rows that we need to set to 0. If that is the case, then we're going to write the result back. And let me just run this real quick. Height not defined because I forgot to type it. Right there. Yes, so the test cases pass, and let's just do a quick runtime and space complexity analysis. Obviously, it's O of n times m, which, what did I say? Something, one is the height, and the other one is the height. Height. So that's going to be a time complexity because we're actually iterating over all of the cells. And how much space? Well, m plus n space, because our hash sets can, for the rows, can at most contain height number of rows, and columns at most contain with number of columns, yeah. So that is the space and time complexity. It's submitted to make sure that it passes all of the tests. Amazing, it passes them. Now the more interesting solution. So the more interesting solution can actually improve the space complexity to constant space. And you might wonder, how does that work? Well, I am going to show you, right? So in order to understand this, this example again, and oh, actually we can just reuse this. Why not? So what we could do is we could iterate, well, the first thing to realize is, let's say we've iterated up until this 4. We are at this 4 right now. If we wanted to use only the matrix space to store information, which is what we'd have to do if we want to use constant space, we have to make intelligent uses of the input matrix. So when we're at this element, we do know that we have processed all of these elements that are on the green side. So that also means we can use all of them to store some kind of extra information if we want. Now the values are positive and negative. So what do we want to do? Well, how about this? Let's say this 4 is a 0. Let's just pretend for a second that 4 is a 0, and maybe this 0 is a 9. Maybe I should use a color. Let's just say, oops, this is a 9 and the 4 is a 0, right? Well, what can we do? Well, we could remember at this X and Y position, we have a 0. And how do we do this? Well, why don't we just write in the top row the 0? Because we know that we need to write, replace all values in this column with zeros anyway. So doing it now is not going to change anything, is it? Same for the first column. We can replace this 3 with a 0. No harm done, right? And we can just continue over the array and continue to do that. So we're using the first, the top row and the first column to store whether or not we found a 0 inside the array. Now there's something that is a little dangerous here. Well, actually, I'm getting ahead of myself. So the second pass over the array, right? If we have 9, 0, 2, 0, and then we have written other 0 here. Maybe we should highlight this. Those are the zeros that we wrote ourselves. There's a 1 here, there's a 3 here. 1, we pretended there was a 0 here. This is 2, this was a 0. 5. Right? So we kind of have this matrix. Drawing, so much fun. Very nice. Okay, cool. Right. So after the first pass, we have this, right? First pass done. Boom. Well, now we can just iterate over all of the cells again. And now we only need to check if, there is a 0 there. And if there's a 0 in the top row or whatever, we can just overwrite these values with zeros that we have here. So this would become a 0. This would become a 0 because there's one here. This would become a 0 because there's one on top. This would become a 0 as well. Right? Right. But we need to be a little bit careful as well, because we must not misinterpret these zeros that we've written for zeros that already existed. And if we mistake a 0 that was written for one that has already existed, could get into trouble where we suddenly have zeros propagating. So for example, when we pass over the array and for some reason decide to write a 0 here, if we run into this value again, and then we suddenly decide, oh, it means this needs to become a 0, then that is obviously wrong. So what we want to do as a precaution is we only want to iterate over all of these elements that we are not going to use to store zeros to indicate that there's a 0 in that column. So we really only consider this this sub array when we decide where we should write the zeros, like here and here. So that is something that we will need to do, and that also means that we have to determine in the very beginning, is actually the first row, does it contain a 0 before we start writing anything in it? And same for the first column. And so the first pass will give us this result. The second pass will update all the cells in this rectangle here with the zeros according to what these elements on top are and to the left are. And then finally, we might have to update the first row or the first column with zeros. And here, for example, since we've written a 0 here, it doesn't mean that we're going to update the entire row with zeros. What means that we're going to update the entire row with zeros is this 0 at the end that was already there. So we need to capture that information before we start writing anything into that rows. Same for here. Just because we encounter a 0 here doesn't mean we want to overwrite these values with 0 as well, because we've written the 0 after we started to modify the first column when we wrote the 0, but we need to capture its state, whether it contains zeros or not, before that. Right? If there was a original 0 here, then it means we need to overwrite the 9. Otherwise, it doesn't. Right? So that's what I mean with propagating zeros. You don't want this 0 here to propagate. Right, so the approach is then, we're going to first examine the first column, the first row, the 0. And yeah, we're just going to iterate over all of the rows and just take the first element. Like so. Same for the row. And there are ways to write this in a simpler way. But I think this looks nicer. You could also write it just equals 0 in matrix, which is the first row, right? Those are equivalent. I'll just keep that one on top because it looks nicer in my opinion. Now, like I said, we need to iterate over the orange part of the matrix, the submatrix that excludes the first row and first column. And we now do the little check here, and instead of adding to our hash sets, just going to use the matrix. At position yx, going to set that to 0, and we're going to do the same thing for position y, like so. Right, so that's a step where we encode zeros in first row and first column, like the pink ones. Right. Next, we need to update all the values inside this inner range. That is essentially the second pass that we already had, and now it's kind of the reversed thing again. So what we do is, if that is 0, and we could rewrite that like so. If 0 in this array that consists of the first element in the current row and the first element in the current column. If that is the case, then we need to set the current cell to 0. Now finally we will take care of the first row and the first column in the matrix. Well, if the first column must be set to 0, well, what do? Well, we set it to 0 for y in 8 matrix at y and x y, position y, and x is 6 at 0. I'm going to set that to 0. Same game for the row. First row must be 0. Now we do x in range width. And here we put in the value x, and for y we put in the value 0. Right. So I hope you can see that. I'm just going to run the test, see if it runs without any errors, and it seems to do so. And if I submit this now, it should hopefully pass all the tests as well. Right. So that's how you do that. And yeah, there's really nothing else to say. That is all you need. And those are the two approaches. One quick one and one that's a little small.